Okay, class, you are now looking at problem number 6 from workbook page 41 being worked. In this case, we are given that line L goes through the coordinates -4, -2, and 2, 0, and point P can be found at 3, 7. So we need to get an equation for line L. In order to get an equation, we need to get in y equals mx plus b format, so we need that m. So to solve for m, it is the difference in y values, so 0 take away -2, over the difference in x values, so 2 take away -4. That's going to give me 2/6, which will reduce to 1/3. At that point, I have the m, so I need to put that into an equation that gives me the slope-intercept form, and I can use point slope. I'm going to choose a point. I'm going to choose this one because it has a 0 in it, and I'm going to do y minus that given y value equals the slope times x minus the given x value. That's your point slope format. And do some algebra. So y equals 1/3 x minus 2/3. So this is my equation for line L. Okay, that it looks like where we were at yesterday on our work. So now we have a point that we need to go through. So we need an equation through this point that's perpendicular to the original line, because I need it to be perpendicular so I can get that intersection point. I found the original slope over here. The original slope was 1/3. So my perpendicular slope is now -3, because I flipped the 1/3 to 3 over 1 and changed the sign. So now I know -3. And I'm going to use point P as the x sub 1, y sub 1 of point slope. So now I'm going to do y minus 7 equals -3 times x minus 3. Let's do algebra. Do some more algebra. And we should have an equation of y equals -3x plus 16. So this is my equation that's perpendicular. Now that I have two equations, I can use a system of equations to find their intersection point. So I'm going to go to my next slide and copy those in. I had the equations y equals 1/3 x minus 2/3, and I had the equation y equals -3x plus 16. At this point, you're welcome to use the elimination method and try to subtract through. Those fractions are going to make it a little funny for you because the fractions do not terminate. So at this point, you're going to have repeating decimals. If you round off, that could distort your answer. We never want to round early. So we might want to try substitution, or if you're going to stay with elimination, you're still going to want to use the fraction method. But because I know y's name is 1/3 x minus 2/3 in this case, I can take this piece and plug it in to the y position of the second equation, giving me 1/3 x minus 2/3 is equivalent to -3x plus 16. So that is using the substitution method. In 7th grade, we call this me-see fraction, me-no-likey fraction. We want to make that fraction go away if at all possible. In order to do that, we find the common denominator or common multiple. We only have 3's on the bottom, so I can multiply everything on both sides through by 3, and I'll have an equivalent expression. So this will give me 1x minus 2 equals -9x plus 48. So let's do some algebra. Let's add that 9x over here, so we have 10x, and let's add that 2 over to that side to make 50. Solving through by dividing by 10, and I have an x value of 5. To get my y value, pick one of the original equations. I'm going to pick the one that doesn't have a fraction, because why add fractions if not necessary? So I'm going to plug in that x value I just got over there to solve for y. So -15 plus 16, of course, is 1. So now I have the coordinates 5, 1. This is my second set of coordinates because I already had the P. So I'm going to take that P I already was given. I was given point P is at 3, 7. Now I came up with the intersection point on the line over there at 5, 1. And now I have 2 points to use the distance formula. X sub 1, y sub 1, x sub 2, y sub 2. Plug it in. Distance formula is difference in x values, quantity squared, plus the difference in y values, quantity squared. Go ahead and work that, and I'll share the actual answer in class. This should be enough to get you going.